welcome to your next set of video notes. In this video, we're going to talk about Lewis valence electron dot structures, which are a lot easier than the name makes them sound. So Lewis valence electron dot structures, or Lewis structures for short, show the symbol for an element and its number of valence electrons. So remember, valence electrons are the ones in the highest energy level, the ones with the greatest value of N for an atom. They're also the ones that determine how an atom reacts with other atoms. They determine how it behaves chemically. So Lewis structures are just the symbol and the number of valence electrons. The steps for writing them are real simple. First, you need to find the symbol of the element. It's the first thing you're going to write, so you need to know what the symbol is. And when we say symbol, remember that means the one or two letter symbol, the one or two letters in the box on the periodic table. So the symbol for carbon is the C, the symbol for gold is AU, the symbol for magnesium is Mg, those one or two letters that you find on the periodic table. So that's step one, find the symbol. Then you need to determine the number of valence electrons that element has. And you can find the number of valence electrons very easily by looking at the family number or the group number or the column number. Those are all ways of saying the same thing. Family number, same as the group number, same as the column number. Find your element, go to the top of the column, find the number there, and that's your number of valence electrons. So then you will draw your electrons as dots along each side of the symbol. And all of our electron rules still apply. So don't pair them up until you have to, because Hund's rule tells us that electrons are selfish, right? Each side of your symbol kind of represents an orbital, so don't make them share a side until they have to, because they're selfish, they don't want to share. So let's see some examples of this. We'll start with hydrogen, right? Always sort of our easiest example. The electron configuration for hydrogen is 1s1. Hydrogen, if you look on the periodic table, right, you have hydrogen, it's atomic number 1, it's got a mass of 1.008. There it is in its little box. And if you look just above it, you will see that it is in group number 1. So the total number of electrons comes from the atomic number, or you can get it from the electron configuration. In the 1s orbital, there is 1 electron. In any case, total number of electrons for hydrogen is 1. Total number of valence electrons for hydrogen is also 1. And this is the important number for drawing your dot structure. So to draw our Lewis dot structure, we'll draw the symbol for hydrogen, and then we'll start drawing our dots around the outside. 1 electron means 1 dot. You can put it wherever you want to. I'm going to put mine right there. That's it. That's the Lewis dot structure for hydrogen. We are going to skip helium for a second because it does something weird. We're going to go to gallium, and then we'll come back. So looking at gallium, we're given the noble gas configuration starting at hydrogen and then 4s2, 3d10, 4p1. If you look on your periodic table, or you add the number of electrons from argon plus 2 plus 10 plus 1, either way, you should get a total number of 31 electrons. Finding gallium on your table, it's going to be in the third group, the third column, which means that it's going to have 3 valence electrons. Remember, this number and this number are always going to be the same. So gallium is going to have 3 valence electrons. We'll come over here and draw our symbol for gallium, Ga. We'll draw our first electron. Then we'll draw our second one over here on a different side. And then we'll draw our third one over here. We're not going to make them pair up yet because there are 4 sides. They don't have to share. So you can think about your Lewis structure as being like a box. Pretend like you're drawing a box around your symbol. That box has 4 sides. So if you have 4 electrons, you'll put 1 on each side, 1, 2, 3, 4. At the 5th electron, then you'll start doubling up. So something like nitrogen, you would draw nitrogen and then 1, 2, 3, 4, 5. Or something like chlorine, you would draw 1, 2, 3, 4, 5, 6. You don't double up until you are out of places to put electrons. So 4 get to have their own side, and then you start doubling them up. The exception to this is helium. So let's take a look at helium now, because it's a little weird. Helium has the electron configuration 1s2. So if we were to put this back in orbital notation, we have one orbital, it's the 1s orbital, and it has 2 electrons in it. These electrons are sharing this orbital. So keep this in mind. Helium is in group number 2. It has a total of 2 electrons. Both of them are valence electrons. So we'll draw our symbol for helium. And earlier I mentioned that each side of the symbol essentially represents an orbital. But helium only has one orbital. We can only put electrons in one orbital, so that whole don't double them up thing doesn't really apply here. The Lewis dot structure for helium looks like this. These electrons are sharing an orbital, so these dots should share a side. So since this is the only orbital in helium, both of the electrons have to be there. So in the helium Lewis dot structure, both of the dots are on one side. Helium is the only one that's like this. Hydrogen would be like that, but it only has one electron. Everything beyond this follows these same rules. Don't double them up until you have to. So pretty easy. Find your symbol, find your valence electrons, draw them as dots, follow Hund's rule. So now you have some practice on pages 23 and 24. Go ahead and work through those problems and then check your answers against the key posted to my website. Please don't just look at the key and assume you can do it. Work it yourself and then check the key. And this is the last video that's really going to talk about where to find electrons. There are 2 more videos in this unit, and both of them are talking more about how electrons behave. So now that we've really nailed down where to find them, the rules that affect where you can find them, now we can start getting into some really interesting properties about what they do while they're there and how they move around. So that's pretty exciting. If you are ready for that, go ahead and move on to the next video. Make sure you are working on your quest. Good luck and happy studying.